photos of it.
Pretty sure it's elite.
Okay, so we're talking about the theory of plate tectonics and plate boundaries. We'll start with Wegener's theory. That is a combination of the famous Arsenal manager and of course Wagner from the X Factor. So 225 million years ago, we were in the Permian age, when there was just one supercontinent called Pangaea. 25 million years later came the Triassic age, and Laurasia was the northern continent, and Gondwana
land.
that one was the southern continent.
Can you show us on the map these two continents, please?
Next came the Jurassic period, 125 million years ago, and following that, 65 million years ago, was the Cretaceous age, and obviously now we're present day.
Show us what the present day is, please.
Today. Where it says today. And then there are several pieces of evidence supporting Wegener's theory. One was the jigsaw fit of South America and Africa, which you can see on that one there. And then there was matching rock sequences of age and type linking northwest Scotland and eastern Canada. And then there was also Permian fossil brachiopods in India, which matched those found in Australia. Thank you.
Okay, so now we're going to move on to the types of plate boundaries. So our first one here is conservative. This is when two plates are sliding past each other, either in the same or the opposite direction. Here there is no crust being destroyed due to subduction not occurring, so there is no volcanic activity or new crust being formed at a conservative plate boundary. Here you've also got very powerful shallow focus earthquakes. An example of this would be the San Andreas Fault in California. Our next plate boundary would be a converging destructive with oceanic and continental plate boundaries. The more dense oceanic crust is subducted underneath the less dense continental crust, and the oceanic crust will start melting and being broken down at about 100 kilometers deep, and it's completely destroyed by 700 kilometers deep. And where it starts melting is marked by the big X. This is called the Benioff zone. And at the Benioff zone, there's a lot of friction maybe occurring, and this can cause intermediate and deep focus earthquakes. Also, at the subduction point or subduction zone, an oceanic deep ocean trench is formed, and also you've got fold mountains being created at the continental crust due to crumpling occurring, and the melted plate will also cause plumes of magma to rise, and this will pierce through cracks in the plate, creating shadows. So, and this can create volcanic activity and andesitic volcanoes. Our next plate is oceanic-oceanic. This is another diverging destructive. Yep, that's what I meant. Converging destructive. And this is either due to a faster moving plate or the more dense plate subducting and creating a deep ocean trench. Again at the Benioff zone, this can form submarine volcanoes and also island arcs nearby, which you can see here. An example of this would be Montserrat. Then our next one is continental. This is another converging constructive. These two plates have a lower density than the asthenosphere, so therefore no subduction occurs and they just end up buckling. An example of this would be the Himalayas, so you've got very big fold mountains there. And here there's also no volcanic activity due to no subduction, and shallow focus earthquakes are also occurring. next one would be a constructed diverging plate boundary. Again, we've got examples of this as mid-ocean ridges, and these can create land 4,000 metres above the ocean floor. And these move due to convection currents, causing the two oceanic plates to diverge. And this will create new land due to the rising of magma, as you can see there in the examples on the board. There are also regular breaks across the ridges, and these are called transform faults. And shallow focus earthquakes and submarine volcanoes also occur at these points due to the creation of the magma and the rising of the magma. Also, when it's at two continental plates, you've also got these cause Great Rift Valleys, for example the Great African Rift Valley, and this is due to fraction of the lithosphere and earth rising, and magma rising. Thank you.